Hello, welcome to Agent Engineering, where we are live streaming agent framework development in Scratch and Go. So this is episode 7, and in this episode, we are going to continue our work developing agent framework. And the today's focus will be integrating our agent framework with deepseek and a locally run model qwen. So let's get started. So let me start by sharing a new way I'm tracking what we're doing and what we're going to do, right? So earlier in our repo, we had a roadmap.md. I have converted that into a Excel draw diagram, right? So I'll just quickly go through. So we are developing an agent framework. Initially, we'll mostly focus on a coding agent like Cloud Code, right? And what we've done so far is we've integrated a couple of models. These three models are done. The two marked with red we're going to do today. Um, we have a basic interface for inference. So these are the two functions we have: run inference and generate structured response. I'll go through the code uh, when we go into it. And for inference, we have done token counting. So any stuff that we query from Anthropic, OpenAI, or Google, we count how much token we use, how much caching we use, and based on the cost sheet calculation, last stream we did how much each session costs us, right? So this is what was done last stream. And then we have our basic agent loop. Our initial agent loop is a Git based agent loop, meaning that currently it's a command line application like Cloud Code, right? But it's a single session setup where we give it a goal, uh, and it can be either an instruction or questions. Then immediately we create a branch for that particular work, right? Then so we have a file system tool that are implemented, that are written here. uh, Whenever we do a write file using tool use, what we do is we do a commit, right? So and that is what our quit flow is. At the end of the agent loop, when it exits, we have a PR for us to review and merge. So this is the current flow for coding agent that we are going with. So as you can see, this is already drifting a bit from how Cloud Code works. So because we have a custom like workflow for our agent loop. So in future, we'll be building more such agent loops and uh, for our agent orchestration stuff, right? So this is where we are at. So as I mentioned, we have also done two. And two things we have kept it on our frontier is sandboxing, right? This is mainly because in one of the streams, episode 3, we were integrating with Gemini, and we saw Gemini trying to read our etc password file, right? So what we want to do is we want to sandbox our agent execution, right? So it should only have certain privileges. So we'll be doing that soon. Uh, on top of that, what we also will be doing is evaluation, right? So based on all these models from all these providers, we want to see which model we're going to use, right? So one simple way I'm thinking of evaluation right now is, let's say, given a goal, right? We can uh, uh, we can send the request to all the models, right? And then decide which one we want to merge, right? Because we're going to have, let's say, 5 PRs, which one we're going to merge. So for that, we need evaluation. We want to have way for developers to select which model is good for which task, right? So later we're going to have like complex flows like routing. So automatically given a task, we will detect which model is best suited for that particular task, given the time the model takes to complete and the token it consumes and the cost of those tokens, right? So we'll be making those intelligent decisions real time. So we need some framework for evaluation to start with. We just put it in our roadmap, right? And what we also need is something like a control plane. Right. So this is again a future thing. We're not going to do any of this today. Control plane is required because it will be a CLI based agent, but we need some UI to see what is happening, right? And this goes back to the article I wrote, that the developers will move from writing code to observing like parallel agents uh, executing some task, right? So we need to have like a control plane where we see what is happening. We want to make this agent work more observable, right? So that the developers can have some confidence in what they're doing. So this is the landscape we are looking at. Currently, we have done the stuff that is in black, and today we'll be doing these two things. One more thing before I move on to the coding part is that last stream I discussed how we're going to test if our agent framework works at all, right? So for that, we're gonna develop a full-fledged application, client, backend, everything on cloud, and we want to develop it from scratch purely by using our agent that we build on live on stream, and this development will also be live on stream. So we so basically we will be working back work from the features that we require for this application, and what how does it translate to how the coding agent features we're going to develop, right? So the reason being that we cannot develop a agent framework towards like a very abstract goal, right? We need some concrete signals from day-to-day development that we're going to translate back into actual agent framework features. So the application is going to be chess tail, and um, I've also acquired chesstail.com domain for this. And a one-line pitch for it is this: the chess tail turns your own chess games into memorable, dramatic stories, like narrative stories, helping you spot patterns and learn faster by harnessing how our brain naturally remembers narratives, right? So, uh, so this is some idea that I have, and I just wanted to test whether this is a valid. And since we'll be building our agent, so this is a good idea that we can try out. So this is where we are at. Let me see how the stream is going before we move into the coding part. Okay. Cool. So this is where we are at. Let's go to our code. Right. So this is the code in Golang. So let me create. So last time the episode 6 I merged in master. So let me create a new branch. Episode 7, right? And we're gonna start by implementing. So just a walkthrough if new viewers are joining. This is main.go where we have our core agent loop, right? And later we will be abstracting it to some like a framework level thing. But for now, this main loop is in main.go, right? So this is the main.go. So our LLM integrations are here, right? Our tool implementations are here, and there are some helper files. So that's mostly what we have till now, right? And so what we're going to do today is integrate with two new models, two new providers. One of it is deepseek, right? And the reason being it's open, right? And we need, and other is cost effective, right? Compared to, let's say, Anthropic, which is quite expensive. Last stream we went into some detail. So I have this cost diagram, some detail on how much each model costs, right? So this is the public sheet anyone can you access. And you can see DeepSeek is much cheaper than, let's say, any of the frontier model, right? So we'll be keeping that as an option for our agent to decide uh, which one to use for that particular task. And on top of this, we'll be doing it on a locally hosted model, which is qwen, and the cost for that will be zero, right? So that is our motivation of why we're doing it, that we want some small tasks to be handed off to local models, which does not cost much, right? Or cost nothing. It just costs the compute that we've already purchased the computer or something. So okay, now the question is which model to pick, right, for coding. So the one that works locally well now currently is Qwen 3, uh, Qwen 3 coder. So this is the model we'll be integrating it. And what we will use for this is Olama, right? So Olama is a open source way for running local models. So it is built on top of Llama CPP, but for now we'll not go that low level, right? So we can just integrate with Olama for now. So I have the model actually downloaded, and if I run it, so it takes some uh, compute from me. I want to check if that will affect my stream anyway. Okay. CPU 10%. Okay. Okay, so the model is ready. So I will ask it some question like which is the latest Go version that it knows. So this model, so local model will be slower as well, plus it will not be like the frontier models, right? So if we are using it for some reason, right, we have to wrap our mind over its limitations, right? For example, this is not that latency. It thinks is 1.22, so so we'll be using it for some stuff. But as you can see, it is quite a decent for local performance, and we'll be seeing how we can leverage this in our code. Okay, with this said, let's so we so one thing is that what Olama does is that it also comes with a web server, right? Where if I open a new window and if I do a curl to Olama, so this is a locally hosted this model, and it gives a OpenAI compatible API, right? If I execute this, so it will do the same thing in an API format rather than this terminal format, right? So this is a good way for us to jump into the integration. And what we're going to do is use the Olama's direct repository. I mean the official Olama repository. Right? So, so it is also written in Go, thankfully. And if you see, it has some integration point. So we will just refer to this and start our implementation. Right. So with that said, let's start into the coding part. Let me create. So the provider here is Olama, and it will be our gateway into all open models, right? So we'll have the same set of. But for now, I will move this here so that it does not interfere with my stuff. Right. Okay, so add a new file. So our interface for this will be mostly same as the others. Right, so we have an implementation. So we will implement this interface, right, which is an LLM interface. We need to implement these two functions, get structured response and run inference, right? So I will get a client. Okay, I have not imported, right? So let me do go get. So this is the repository. This is the Go module that we need for this. So we got this. Let's save a client. This is from Olama's API interface, right? Let's create a new LM returns. It doesn't take anything. let's write an example. Okay, okay. Before that, let's do the client from environment, right? So basically, it depends on some environment uh, variables for the host port, like Olama host, we have to set, right? And we don't need any key, right? Because we just need host, right? So we in this .n file we need to set Olama host. I'm not going to open this .n file on stream because it has secret API keys for Anthropic and also I'm not going to expose that. But let's complete this part. Return, yeah, yeah. So return error there, right? So we return this client. So here we initialized our client. Now let's implement these two functions. Interface. Okay, right. Let me copy and go Olama, paste that here. So this is func Olama. Same thing here. Oh, right. Hmm. Let's just write the simple one first, which is this. Right. So basically, we have getting a bunch of messages, and so what this get structure responses, we will get past a type or pointer to a particular go type, right? And we have to populate this and return, right? So this is basically get a JSON. We use currently this for, if I were to show you, currently we use it here where we are saying given the initial goal, give me the name of a branch to be created, right? So we use this here, get structured response. And here, if you see what we pass it the messages, which is just this thing, and we pass it a pointer to a struct, which is this, right? So we just have to pass this particular struct and it populates it and gives an instance of this here, right? So that is what this function is. So let's start actually, right? So we will be using right. So o dot client. Let's see what we have. Right. So there is a chat interface with context. Let's pass it background for now. And it requires an API dot chat request. What else? What else is required? Chat. What is this thing? Chat generate next message in the chat may contain a sequence of messages which can be used. Maintain a chat history. Function is called for each response. There might be multiple. Streaming is unable. For now, let's just do this, right? Tools. Okay, so there is no response format for this. So I think we have to use a trick that we do for uh, uh, Anthropic, which is we generate a fake tool call generate struct response, and we pass it as a tool call, and we say that use this right as a tool choice, and then whatever tool call we get, we unmarshal that particular thing. Uh, so we have to do the same trick for qwen here, right? So because there is no response format. So let's say the model is qwen free coder, right? That is there. The next thing we need is right. So llama messages, right? We do this transform to llama messages. We need to implement this, right? And here we pass messages, and then let's create a fake tool basically, right? It will look like tool. Okay, so what should a tool have, right? Type is data tool type. What should this be? Tool function. Okay, I think that is the type is function. Okay, let's come back to this. For now, I will add function. There is my Olama code. Name, generate, structure response description. Let's keep it the same as goal. Let's keep it same as Anthropic, right? And then we need parameters, right? So these are the three things in the function. And now here, as our generic rule, what we do is we create a function to convert generate Olama. So we create schema and we pass it the pointer to this guy, right? So this is also something we have to create. Tools. Actually, let's just write the function here, right? Let's just do nothing here. We'll see why this is required later. Right. Okay, we need this function and we need the transform function, right? So this is a common thing that we do for each of our integration, right? Right. Messages. Okay, let's complete our main function so that we can jump on to implementing the individual stuff, right? So once we get what does chat returns? Oh, okay, it returns error, so whatever response we'll get will be here, right? So that is why this is required. Okay, error, if error not to nil, we just return from here else. Else okay, because this is if response, what does response have? Response has message and it will have tool call, right? Okay. If length of response dot message dot tool call greater than 0, then tool call is equal to, actually we just pick 1 because we are sure that it will give just 1. Response dot message dot, right? So we ask LLM that give us a tool call, and just we are just picking that. Anything else is nil, right? So we just return from here, right? And then actually we have to check if this is nil, right? Even after this, if tool call is nil, return error. Let's say tool call not right. So this is a failure case, right? Else what we do is we do JSON dot unmarshal, right? We unmarshal the tool call dot function dot parameters dot, okay, the string, okay, into response, right? This is what our instruction for this function is, that the JSON returned from LLM parse it, unmarshal it into this, right? Let's convert this to bytes. If this fails, then we just return the error, else return nil. Oh, this first nil is the metadata, right? Okay, we need to populate that and return. So metadata here. So in each call we are returning a metadata. The cost here is 0 because it's the local model. Time, we have to return something, right? This is because the time cost for this is not 0, right? So we start time dot now, and at the end we say time taken is time since start. And here we return time taken, right? Cool. This is good. Okay, my mother is saying great job, good. So thanks, mother. Right. Let's continue. What's wrong here? Should it be a what's wrong? To call. Okay. Okay. Okay, there's some mismatch in types. So this is what we want to do, right? And this is what we want to do. Let's hold off the implementation of this until we also write our run inference, then we can go ahead from there. So the run inference should be more or less the same, right? Not completely same, right? For run messages, what we want to do is Olama tools. We have to change from our tool definition to Olama tool definition to Olama tools, right? And return here, right? So, okay, this fake tools we don't need now. Olama tools, right? And this handling we have to remove. Let's do a to do here. And we need time taken, we need error handling. So we return three things, right? So we return a metadata, or the first is messages, then we return metadata, right, cost and time. Cost is okay. So this is again 0 because this is a local model. Time taken is this. Right? So we return this in even in case of error, the time taken is not nothing, right? So we have to account for it. Okay, dark mode. Byte Banter says please use dark mode. Okay. I kind of like the light mode, so okay, just because you're saying I'll change. Let me see. Let me try the appearance. Let me try to use the dark mode and see. Okay, hope that helps. Okay, I might take some time to get used to it. Okay, where we get? So we have the tools. We don't need this. We send the messages. We send the tools here, and we have to process the response, right? So our response is api.chat response, right? So let's just save it here. Response is equal to this guy, and here we have to transform from llama message and to response dot message. Oh, why is there a single message here? Why can't there be multiple messages? Okay. Okay, this is where the ulama people have. Okay, so we need an array to this, and each time we call this function, we need to append to this, right? Response, right? And here we send this is ulama response. Copy. So here we return response messages. We return this guy. Return nil error. Right. Okay. So we've written all our implementations. Now what we have to do is to do is implement all these functions, right? Right. So let's get into it and finish it. Yeah. Create a function. What it returns is, what should it return is array to api dot message, right? Let's write it at the end. It's this is the boring part we have to do for each. Right, so we switch on m dot type if case. So basically our messages comes in different types: text, message, tool use, and tool result, right? So we have to do this message, text, right? In this also, let's role is user first. If m dot role equal to role assistant, role is assistant, right? And then out is append message. We have fields. Okay, what the role content should be text. Okay, this is all not needed, right? If the type is message. Case message tool use. So tool use is always assistant, right? And tool call ID and tool calls. Why is this here as well and here as well? I don't understand. Okay, let's pass everything. Tool call ID is m dot tool use dot ID and tool call name m dot tool dot name. Tool calls. Why does it require the whole tool calls? Tool call function. It needs the whole thing again. Okay, let's just send it. SM tool dot ID. We don't save index anyway. What does it require for ID to be? Okay, map of string any, right? Input is raw bytes, right? Let's convert this into our args map of string any json dot marshall args tool use dot input, right? Okay. I think this function is okay. One thing is remaining is the just hold it here. This message will result out role is user content is preserved. So we don't have name here. Tool name. Okay. Right. Okay. So this transform thing is done. Right. So this function is done. So we are converting our representation of messages to Olama's representation of messages. Right. Let's do the opposite quickly so that all right. So here actually we have to only switch on type. Okay, what does it give us for message to reports? In response, what do we get? We get a message. We have to say if m dot message dot we have to iterate through all two calls actually, right? And then how do you append to, first of all, types is message to use and to uses or it, right? To the id dot function dot name dot argument dot string convert to raw message thought signature. Okay, this is only for Google, right? We found out yesterday, right? So that is, we add to tool call and then if m dot message dot content is not empty, then we add out when type message text, right? So this is how we transform. Then we return out. Okay, this is also done, right? Okay, now two functions are remaining, right? So the first function is the transform. This should be the simple one. Type, okay, the type, this type we have discussed that it's function, right? Function has a name, description, and parameters. It should again be generate Olama schema dot instance, right? Turn up, right? Okay, now only one function is remaining, which is Olama generate schema, right? So it takes this instance and returns it to. So as a matter of time saving, I had already implemented this thing offline because it's a bit tedious. Just paste. I will go to the code here. Let me rename it to generate Olama scheme, right? So the reason I did this offline is because so Olama library has a very weird way of defining function parameters. So like how all the other frameworks, they do JSON schema, Olama has its own way of doing it, right? So it requires something like this, right? Where it this is the top level type should be object, right? And then in properties, it is a map of string and tool property, and the property uh, is again nested, right? It again has properties, and it has description, or it can be enum, right? So this is a very uh, weird way of doing JSON schema. I don't know why they just didn't do JSON schema, because everyone is trying. Actually, let's go here. Off stream, I'll create an issue here to create support JSON schema. Okay. Hmm, TypeScript type string. Okay. Wow, that is so weird. Okay, so for this purpose, what I've done is I've implemented is offstream, right? So what we do is take our instance, do reflection, right? And uh, we initialize all the stuff, right? All the properties required string. Then we iterate on the fields that we have and get the data. We create the prop. We add, if it's required, we add to the required, and that's it, right? So this is required, and generate tool property in JSON field are the three implement functions we have to implement, right? So the generate tool property is take a reflected type, right? What else we give? Type and a tag, and then we create this API tool property. So again, this is when we do reflection, we get it can be of any type, string, bool, right? So for each we have to create this kind of tool property stuff, right? So that is why I did it offline. Otherwise, it's too much to do on stream, right? So this is how we convert to tool property for any kind of so is required. We see whether the JSON tag is there, right? Whether it has omit empty, and the JSON field we get tags from the struct. If it has a JSON tag, and whatever the value is, we just return it as, we just take the first one and return, right? So enum values is if the tag has enum, because that is also supported, right? So this is our implementation of generate skill. With that, I think the whole implementation for Olama should be done, right? There's doesn't seem to be any error, so we can start from there. Let's integrate it, right? So if case is Olama LLM, I think it returns error as well. Right. Now upstream, I will add the host in the environment file. So the host. Okay, I've already added, thankfully. Let me close this and come here. Right, I've added Olama host. So if I do go install, because there's some issue, I do go mod tidy. Okay. Oh. Now we're gonna ask Olama to explain this project to us. Right, this is this to Olama. So our agent works on a Git repository, so it's I found a Git repository, it will create a branch. So the first call is to get what branch name might be, right? As you can see, this is super slow. I don't see how we will be able to use it as any kind of a way. But for now, we just need an option to use open source models. But if it's this slow, I don't think the main agent will decide to use this. Oh wow, this is super slow. Let's wait for some time. Let me open system monitor to see what is happening. Right, so my system my OBS. Okay, so it did create a branch. It took 1 minute 17 seconds and $0, and it created the name for the branch for this kind of query, right? So it created project explanation. So that is some success that we have had, right? So the generate structured response function is working well, right? Now we want to see if the tool use are working well. Just wait for it. I think we should add more logs for us to see what is happening. But it is okay. So the tool use is correctly chosen, right? So for this thing, the tool use is required, which is read the current directory, right? So we return the tool result, right? Now it says, okay, read the git directory. I don't know why it is reading .git directory to understand this project, but the tool use is also working. So I think this is a good just saying that in our first implementation we got the Olama integration correct. The only problem is it's damn slow, right? I mean it's 14 seconds for, so we can see like if we can tweak it a little bit to make it a bit faster. But our open source model integration is the, yeah, cool. I think this is good progress for. Also, we are almost at the end of an hour, so I think this is a good place to end this stream, and we can continue with DeepSeek integration next stream, which is going to be next to next weekend, because I'm off next weekend. I'm going to vacation in Vietnam, so yeah, I think that should be it for the stream. Thanks everyone for joining. See you folks next stream. Thank you.